Okay, good morning and good noon, and thank you for coming to this session. As the title said, this session is going to be observability data on the data lake, powered by some graph query engine called PuppyGraph. My name is Eric, and I'm from Coinbase, and this is Dan Feng from PuppyGraph. My coworker Xinyu cannot come to this presentation today. I'm sitting in for him. So thanks for your interest about. So we're going to cover about a few things. One is what problem we're solving here, right? Observability is a very interesting and fast-growing sector. So we're going to talk about how to leverage data lake to complement the other observability solutions like Datadog, Splunk, to give you better business insights about it. And we're going to talk about a few use cases we are solving at Coinbase. And of course, we're going to talk about the Databricks technology integration, including Unity Catalog, Credential Vending, and how do we leverage additional non-Databricks computation engine on top of a Databricks infrastructure so that you have choice and you can make the most of your Databricks investment, right? And we're going to talk about what we plan to do in the future. And hopefully that will give you some of the ideas and inspiration, right? So first of all, what is observability data? So observability data mostly are metrics, logs, and distributed traces. These are the three pillars for observability data. They're all time series based. So what we normally do is using time series to plot them out and see what are the events and activities happening at the same time. So you can correlate to that. This is what the Splunk and the Datadog did. What happened? Sorry. Okay. Am I audible?
It's back again. Okay.
Okay. So let's continue. So the majority of observability data are plotted and reasoned based on the time series, right? But then as the business grows, you have a more complicated use case. You want to correlate your particular user ID to see what this particular user has generated the events and what kind of order we're getting stuck, or which particular service are generating too many retries and generated the storm of connection to the downstream application that cause a congestion, right? All this like a deep dive analysis, you kind of need better analytics, which is kind of expensive and hard to provide. So one of the common problems that we're trying to complement for the existing observability data platform is more like, say, how can we augment the rich, huge volume of observability data with your business domain data together, right? So I'm going to give you a little bit volume metrics here to see how big or how complex the problem is. So at a daily basis, we can generate 18 to 26 billion just trace data. That's in billion, not a million. And after the storage optimization we did with partition by time and sub-partition by the trace ID and all the prefix, and we do the Z ordering of all the frequently used predicates filter. So that is trying to make the query we're going to do at a later time much more performant and efficient. Because if you look at the volume, right, you have 1.6 terabytes to almost 3 terabytes data generated a single day. And if you want to query this one very efficiently, your data layout needs to be optimized accordingly, right? So this is something we're talking about. So compare with Datadog and the other system, now you are able to keep the data for longer time, right? Typically for cost reason, you can only keep very short period of time in Datadog or Splunk. Otherwise, your cost is going to skyrocketing, right? So in this architecture diagram, and you see we just have a mechanism to use the gateway to duplicate, or we call dual publish, the Datadog traces data to both the internal system on data lake in the real time with minimum latency, but at the same time, we are not affecting the Datadog path itself. So in this case, this is a non-disruptive way to fork your data for additional analytics purpose. Well, we're going to talk more at a later time how we can use PuppyGraph to handle the huge volume of data with affordable cost and couple of use case here. So now spend a little bit of time to explain the traces data structure. This is a kind of like an open standard. This is not specific to Databricks, Datadog, or PuppyGraph. This is the industry standard. Something called a trace is a series of activities happening in your microservice ecosystem. Every bar you can see here is kind of like a time span of an API call in one of your microservice. And a series of them combined together is one thing called a call graph or user journey, right? And we need to kind of like combine them together to form the full picture about what happened for that API call coming from a mobile apps, enter your API gateway, and expand through your kind of like a fleet of a microservice farm. And then you can see there's some complexity about this one. And naturally, this is going to be a huge volume of data your microservices are generating every single second. How do we make sense of this data? That's the challenge that the Datadog Splunk try to solve. And today, we are helping you to think about the third one, right? Which is, how can we analyze this data in Databricks with the help with some of the graph query engine, right? So here we're going to talk about a more specific use case. So from that call graph and traces telemetry data, we can first compute something called service graph, right? It's a topology about which service call which service, and then we can augment the additional data on top of it, like how many calls are from service A are to service B. That's the easy part. Then the next level is between the call from service A and B, how many of them are returned within the latency expectation? How many of them were beyond the latency expectation? How many of them returned with error code? And when we augment and aggregate these numbers on top of it, your topology graph is no longer just the lineage. It is a live data to show you, are we operating in the healthy state? Do we have a performance degradation? And how are all these problems are propagating through your topology? Now you can zoom in and see where the problem is and trace back. Where is the root cause of the problem? Because when you have a service degradation, typically it could be widespread, but it's not everything is falling apart. It's about one or two choking points spreading the pressure over your topology. That's where this powerful analytics can really help us to narrow down and figure out what's going on when and what is wrong. All right? Okay. The next one is we're going to talk about how this is happening. We have the data volume. We have billions of tracking points. We have terabytes of data every single day. And typically, when something wrong, some incident happened, we don't need to scan the entire days of data. We zoom in to maybe up to 2 to 3 hours of data. And then we connect them to form this graph. Now, I'm going to invite Danfeng from PuppyGraph to really explain how this can happen on top of a Databricks infrastructure and what kind of analytics they do and what kind of a mechanism, and we leverage Databricks to make this one as easy as possible, and so that you can reuse all your data lake investment on top of the open table format, like Iceberg and the Delta. All right? Please.
Thank you, Eric. Yeah, so as we've seen, right, we've seen the power of the graph on the screenshot, right, like the metrics or this like distributed tracing graph helps. The issue is like with the tremendous amount of data in Databricks and like terabytes of the like data volume like generated every day, in many cases it's actually impractical, or it's really hard, or it's like not efficient to actually have the ETL, like populated data into a different database. And the way PuppyGraph tackles this problem is different. It's not a graph database, it's a graph query engine where it actually queries your Databricks data directly and build a graph model on top of that. So in this today's session, I'm going to talk about two important features. One is like how it supports credential vending. So it seems to integrate with your Databricks data to securely and query your data in an integrated way. Second is how it supports the same like popular graph query languages that are supported by other like graph databases, so that all the like tools, all the integrations that were working will still continue to work. So the first thing we're going to talk about is the credential vending. And this is like a diagram of the credential vending feature of how PuppyGraph talks to Unity Catalog. And the data are actually stored in like Databricks. In this example, they are stored in like Delta format, in Iceberg format, stored in S3 buckets. The issue with without credential vending is PuppyGraph needs to talk to storage and process graph queries. However, in many cases, the authentication or the auth of the storage is managed separately. So in this case, we need to talk to S3, right, to get the data, to get, for example, the actual files, like Pocket files back, to do the graph analysis. With credential vending, what actually happens is when the first step requests come in, PuppyGraph will send a request to Unity Catalog, which is a step 2, to get the temporary credential vended back from Databricks like Unity Catalog on step 3. And that credential is downscoped because it only allows PuppyGraph to access a specific subpath of the S3 bucket that is corresponding to the tables it is looking for. And it also having like a time limit. It's like not like long term. So that reduces the risk of like what if like some credential is leaked, or it's like it reduces like the possibility of like the credential is like externally retrievable by other tools. So the next step, PuppyGraph will send the temporal, use the temporal authentication, talking to the S3 and buckets and accessing the Delta table, and fetch the data back and process the graph queries and send it back on step 5. So this is like a general flow of PuppyGraph leveraging credential vending, and this is really like a safe integrated approach because everything is managed by the Unity Catalog. PuppyGraph doesn't have to worry about a separate setup of the credentials. This is like the, this is like the, this is actually a concrete request PuppyGraph has and sent to Unity Catalog. We have the credentials fetched by sending a post request to the temporary table credentials API on Unity Catalog. And it is actually specifying the table ID, where it's like we are interested in this table and we want to actually use the data inside this table to process some like graph queries. And the response from Unity Catalog is a temporary pair of access key, a secret key, and there's a session token. And what is more important is like the expiration time, which actually indicates it's a short-term credential. It's gonna like stay there forever. And PuppyGraph actually manage the expiration, and when it needs another session token, it actually talk to Unity Catalog again for the consequent like queries. So this is a part of the credential vending. With this, PuppyGraph can securely access the data storing in Databricks. Now let's take a look at what kind of applications we have on top of the tracing data. So this is like the first use case we're going to describe. This is like the service dependencies. The idea is like we have different nodes in the graph, and each of the node represents a specific service in our use case. On the left side is just like one of the graph queries written in Gremlin. So this is one of the popular graph queries. PuppyGraph also supports like Cypher, which is another popular graph query language. This graph query actually just like starting from some specific service, and it treats it as a node, and want to do some like fan out, traversing along the edges like defined in the graph, doing some traversal and sending the result back. And this is like a screenshot of a PuppyGraph like query interface. On the left side, you put in the query and send it out, and on the left side, on the right side, it returns a result and visualize the service graph. And this is actually like not the whole service, not the full service graph, but like a portion of that corresponding to the query response that we have on the left side. On this one, we can look at the query result and explore the response of the traverse graph interactively, click on the specific nodes, and it will return the actual information. And this output can also be integrated with any kind of like Golang, Python, or other like JavaScript like APIs, so that it can be integrated further with other services of the service graph, like and root cause analysis system. Once we have this service graph, what we're going to do in the next step is like we have the another graph query, and we want to augment the service graph with additional information, because in a real like reality use case, right? Like beside the discrete tracing, we will have other types of data. And one thing is like we use the raw trace data here. We have this query actually computes the error rates derived from the discrete tracing data. So this on the left side is a Gremlin query, and actually computes the error rate for this specific service. The idea is like on the right side we have the error rate computed. So imagine the use case that we have mentioned at the beginning of the presentation, right? We have a service graph, we have the data populated into Databricks, and we want to actually understand what actually happened, let's say within last 30 minutes in our server infra, and what if like some service went down, and what's the impact on the downstream? What's the impact? What could be the potential causes from upstream? And this kind of like graph queries integrated with the queries that we build for the service graph, put them together. It's going to be augment more and more information and provide more and more insights for the to build a comprehensive view of what is actually happening from observability, like use case perspective, and it's providing more information. All of this is happening with the data living in the Databricks and built on top of, with the graph capability built on top of the Databricks data brought by PuppyGraph. Yeah, so we briefly wrap up the use case that we had at Coinbase, and we like to talk about some future innovations. First is like we want to actually, first two are the use case innovations. We want to actually expand our use case. We want to bring in more and more different type of data to augment the existing service graph we have built. And we want to also, instead of like only supporting the analytical use cases, we want to actually expand it to like graph-driven anomaly detection, so that we can proactively see what is actually happening and to sense any potential issues before we actually notice the downstream like impact is like growing. The other part of the innovation we plan to do is like the technical part. We want to actually spend more like effort, improve our incremental graph data processing, which means instead of like computing all the graph queries from scratch from beginning, right? We want to actually introduce ways of like saving intermediate results and do that in an incremental way, so that the next time we do the graph queries will be on top of the existing graph queries. And we also want to introduce a high efficiency data structure, so that it can be more closely integrated with open table formats like the Databricks, like Delta table, like and then like the Apache, like Iceberg, so that it'll be powering more and more like use cases and more like bigger scale of the problems. Yeah. So with that, I think that's the presenting for today. We have question time. We have this like Delta Lake swag, right? Like,
Yeah.
for any questions.